All right, so going through this experimental design diagram, our independent variable is going to be temperature, and then the other one is going to be organism. So we're looking at mealworms and dry/germinating beans. Okay. The reason why you can have two independent variables here, and it's not a huge deal, is because like you will be able to control for like we'll be able to there's going to be a station where one station is just looking at each of these organisms and how they do cellular respiration at room temperature or at like a warmer temperature. So there's nothing that's going to prevent you from this being like a contradiction. And whenever you make your graph, you'll have a line that would go with the mealworms or a line that goes with like the dry/germinating beans. Okay. All right. Now this is kind of interesting. What are the levels of the independent variable? So levels of the independent variable. Don't think levels like Mario. Levels is what are the different ways you change the independent variable. So how are we going to be changing this independent variable? Aditya? Yeah.
For temperature would be like warm, medium, cold.
Yeah, right. So you'd have the different temperatures. So you'd have warm. I said we're going to have room temp. If you're, as proper, we're just saying warm because I have some heating pads in the microwave. It's hard to get an exact temperature. Ideally, you would have this at a specific temperature. Same with room temp and with cold. If you look I posted the lab in Schoology, the instructions. So if you look at it, I give you a specific temperature, but anyways, it's going to be more of an approximation for our purposes. Okay, but then. What about we have two IVs, two independent variables. What would be our second, for organism? How would we say that for levels of the IV? How are we changing the organism independent variable? Switching the organ, yeah. So you'd have mealworms, that'd be one. That's one. You would say one level. Another level would be dry beans, and another level would be the germinating beans.
Oh, they're different things.
Yeah, the germinating beans, they smell awful. They oh my god, it's so gross. I actually almost just threw it on. Could you imagine? I just okay. So here's your dry bean, and then if you germinating means the bean is starting to grow. It's breaking out of the shell here, and it's going to begin turning into a fully grown plant. So there you go. All right. So then let's go over the dependent variable. So let me scroll up here. So then we went over the independent variable. So then what would be our dependent variable? What is we call that the DV. Dependent variable. What is going to depend? The dependent variable depends on the independent variable. Or another way of saying that is, what are we measuring or collecting in this lab? What are we trying to actually test? Yeah, go for it.
The rate of cellular respiration.
Yeah, cellular respiration rate. So rate of cellular respiration. And then you want to put your units that you're measuring in parentheses. So this one's kind of weird. It's CO2 ppm. ppm stands for parts per million. So you'll see that even in water testing, it'll be ppm or air quality. So it's how much parts would be how many individual CO2 molecules are there for every 1 million other molecules. Okay, so if you had if there was 1 ppm, that'd be 1 CO2 molecule for every million other molecules. Okay, and then per gram. So where the gram's going to come in is you're going to try to measure out. Say you're going to measure out 15 grams of your beans. So if you got 20 CO2 parts per million. You would then, and you measured 15 grams. You did that with a 15 gram sample. What would be your CO2 ppm per gram? If your sample was 15 grams. What did you say? Yeah. You divide it by 50. You divide it by the gram sample that you had. Okay? All right. Make sure that's clear. So in other words, you're gonna get your reading, and I'll show you. You're gonna have to like download Logger Pro and stuff, and you get your reading, and you're gonna get a slope, and you're gonna have to divide your slope that you get by the gram sample that you used. All right, and then let's do control group. What would be the control group? Or do we have one here? So it's the control group is what is something that's not going to be receiving any changes. So we're going to help to use to compare the results. Room temp, yeah. So room temperature, that would be our control group. Control groups, some experiments like control groups are better than others. So I don't think this experiment like the room, like something like a classic example of a control group would be like medicine trials. Like if you're going to be testing like, does this medicine work? You give a placebo medicine like a sugar pill. And so that way if somebody like, because what can happen is people might like feel better and actually get improved like say blood pressure, but it can be a psychological thing. Like it could be their mind playing tricks on them. So you randomly give, like I would give like this half of the room the placebo, the sugar pill, and this half of the room the actual blood pressure medicine. And if we see a statistically different difference, right, the error bars don't overlap, then we would know, oh, okay, that medicine's actually doing something, and it's not just the concept of you taking a medicine that makes you feel better. Okay, constants. What's going to be staying the same in this experiment? This one's a little more like common sense. Like, what am I keeping the same? Say weight? Yeah. Ideally, the mass would be the same. Now, for the worms, we don't have enough worms to keep it the same, like to do 15 grams. But like, yeah, ideally, you would keep the mass the exact same. Well, you're measuring CO2 with a probe. We're going to use the same probes, right? I'm not using like Vernier Lab Pro and then like Great Value brand Lab Pro, right? We're using the same brand Lab Pros, same age. You're then gonna you'll put your sample in this bottle here. We're using the same bottles. And then you would then like your sample's in here and then your probe's in here. It's measuring the CO2 being produced. So yeah, we're keeping all of that the same. We're doing it in the same classroom. So like the room you're in would stay the same. So, I don't know, you can end up making a pretty long list, but those would be like some of your constants. All right, and then finishing this out, repeated trials, what would that be? How many, let's say like hypothetically all 8 groups were doing this experiment, right? Like, I know we're doing it kind of weird, there's like 4 different groups. What would be our repeated trials if everybody's doing the same experiment? So it's 7? We have 8 tables. So it would be... Oh yeah, right, sorry. You're repeating 7 times. You're doing a total of 8 trials. So depending on how they ask, you're repeating 7 times with a total of 8 trials. If you would then include all my classes, it would then be 15 repeated trials, or you're doing 16 total trials. Okay? All right, cool. And then finishing it out, I think we got 2 more, hypothesis. So when you're doing a hypothesis, the standard kind of formula we teach you is if IV, then DV. And your hypothesis is an educated guess or prediction. So what do you think is going to happen? Okay, so what would be like a valid hypothesis here? So you got to stake your claim on something. Pick one of our independent variables that we're changing.
You lost me.
So your hypothesis, if IV, then DV. Let me give you an example. If we raise the temperature, then respiration rate goes blank. You pick. Goes up, goes down. The rate that you measure, how would it change? Okay. Yeah, go for it.
What about the mealworms versus the beans?
You could make you could do one for that. If you're a mealworm, then respiration, the the respiration rate of a mealworm will be blank compared to some other
So do
organism.
we write like two hypotheses for the temperature and then the?
You're not actually you're not turning this in. This is just like some notes to help you out for like the quiz next class. But like if you were to write a there's no Google Doc for you to fill in. It's just trying to get you to think of like what could be an acceptable hypothesis. So you could have multiple hypotheses theoretically. Like there's not one right or wrong answer. Aditya? Yeah.
If you use mealworms instead of respiration, high cold temperature and
Good. Okay. That works. All right, and then the last thing is title. So, especially with like middle schoolers, a lot of them want to just be like, worms. I have worms, like, I don't know. They don't want to say some title that like doesn't like kind of is vaguely related to the experiment, but what you got to think about like the title, like think about the title of your graph. The title of a good graph would be something that would like, I could look at the title of that graph or that experiment and I know exactly what that experimenter did. Like if you're a research scientist, you want to be able to read the title of a research paper and know exactly what they're doing in that experiment. So what could be like a valid title of this experiment? Oh, and the formula is the effect of the IV on the DV. It doesn't have to be written in that form. It's just to try to like give you a way to think about the title. You just need to include your independent variable and your dependent variable in a good title. Yeah, go for it.
The effect of different temperature on the rate of respiration.
The effect of different temperature on the rate of respiration. There's something else you'd want to add in here. What could be something, like one other thing we could add in here? Considering, because we hit one of our, the effect of temperature.
CO2.
The effect of temp on the rate of it. No, CO2 is fine. But remember, we had two independent variables. This hits one of them. So how can we include the other one? Go for it.
Oh, the effect of temperature and the type of organism on the rate of cellular respiration.
So we could, yeah, right, including the organism. So the effect of temp on the rate of respiration in mealworms, dry beans, germinating beans. Like including, in other words, our other organisms here. Okay? And again, there's other ways you could reword that title. There's not a right or wrong way to do that. It's just making sure you include your independent variable and your dependent variable. Okay, I'm going to go ahead and stop the recording here.